Yesterday, I went over solving quadratics by factoring, and it was just basic factoring with trinomials or GCF. Okay, remember you can either take out the greatest common factor if all of the terms have it in common. Okay, and with the trinomials, the quadratics in trinomial form, we were able to use the X method. Okay, what we're going to look at today, I'm going to put the same thing that I put on yesterday's notes, okay, like a little key for the types of factoring that we might use. And remember, we went over all these types of factoring earlier in the year. There was GCF, greatest common factor. Okay, there was difference of two squares. Okay, so that's when you have a perfect square minus another perfect square. Okay, and then we had the X method that was with the trinomials. Okay, and then we have grouping. That was when we had the four terms. Okay, so those are the types of factoring that we have reviewed this year and practiced. Okay, so yesterday's notes, we focused on solving quadratics with GCF and X method. So today we're going to look at some examples with difference of squares. So as a reminder, here's like the formula for difference of squares. You have a perfect square minus a perfect square. It's going to factor into two nearly identical binomials. Okay, with the square root of the first term as the first term in each binomial, okay, and then the square root of that second term as the second term of each binomial. And the only difference, I said nearly identical, because one is going to have a minus and one is going to have a plus. Okay, so when I look at this one here, and I'll do some highlighting here for you. So we take the A value, what the square root of this first term goes here and here. And then B, which would be the square root of that second term. Oops, didn't mean to highlight the minus. Goes here and here. And then you just remember you do put one plus and one minus. Okay, so that's how we're going to break this down. Okay, so what is the square root of this first term? If this is like a squared, what is just the a? It's just x, because it's x squared. It's just an x instead of an a. So x is going to be the lead term of each binomial. Okay, and then I'm going to have one plus and one minus. And it does not matter which one is the plus or the minus. You can switch those and do the plus first if you like that. And then I need to decide what is the square root of this second term. Okay, so what is the square root of 36? 6. So some people get confused and they're like, how come it was a b squared here and we just wrote b's? Shouldn't we just write 36? No, this was b squared. We didn't write b squared in each of these. We wrote the square root of b squared. 36 can be rewritten as 6 squared, if that helps you. Okay, so that's why we used a 6 in each of those spots. Okay, now we have done that, just the factoring. You should be able to do that. Now what we're doing with that is solving the equation. Okay, so this was all set equal to 0, so we're going to keep it set equal to 0. And like I said in yesterday's notes, once we have our factors, okay, we're going to split and solve. So I like to draw that line down to separate the sides, okay, and I'm going to split and solve. So I set each factor, so x minus 6 and x plus 6, each of them separately gets set equal to 0. Because if either one of those comes out to 0, the whole thing will come out to 0. Okay, because we're multiplying these two binomials. Okay, so then to solve on the left, I would just add the 6 over. which would leave us with positive 6. And on the right, I would subtract the 6 over, which would leave us with negative 6. Again, I mentioned this in yesterday's notes, but just as a reminder, when your binomials or your factors are just a binomial of x plus or minus a number, okay, your solution is just the opposite sign of that. So this was x plus 6, so the solution is negative 6. Okay, that's what would make this 0. This is x minus 6, so the solution is positive 6. That's what could be plugged in here and make this 0. So some of y'all can go straight from the factored form to the solution without having to show this work in the middle, and that's fine. Okay, if you're not to that point yet, that's okay too. Show that work so you understand where these numbers are coming from. And again, on the graph, what do these solutions represent? The x-intercepts. If I were to look at this in Desmos, if I were to graph this, I'm just looking for the x-intercepts. These are the points where the graph crosses the x-axis. Okay. All right, here's another one that's in a difference of 2 squares. We've got 2 perfect squares. So I know it's going to factor to my 2 sets of parentheses. And I'm going to have 1 plus and 1 minus. Okay, so what is the square root of x squared? Square root of x squared is just x, right? If you need to see that, where's that coming from? If I have x squared and I take the square root, the square and the square root cancel each other out and just leave us with x. Bless you. Right? The square root of a square, that operation just they undo each other. They negate each other. So that's just going to be x. Okay, what is the square root of 144? 12. If you need to show that work, the square root of 144, and you can do that in your calculator if you don't know your perfect squares, comes out to 12. Okay, 144, remember, can be rewritten as 12 squared. That's why this breaks down to 12 and 12. Okay, now I would split and solve. So x minus 12 equals 0, x plus 12 equals 0. So I have my solution of positive 12 and negative 12. Because I would have to add this 12 over. If you need to show that step, you can. I would have to subtract that 12 over. That's how they end up being the opposite sign. Now, yes, I want to show you something. That is using the factoring method of difference of squares. But I want to show you an alternative. Because there is only one x term, there's an x squared. There's no just x. Like these down here have 2 x terms. Okay, you've got an x cubed and you've got an x. Okay, that one we would actually do GCF factoring. Okay, and on the back, you've got an x cubed, an x squared, an x. You've got multiple x terms. Okay, so you have to factor. Here, though, there's only one x term. So technically, I could solve this by isolating the x. So I do have an alternate method that I would be able to use to solve these. Okay, so I'm just going to say, I'm going to rewrite this, x squared minus 36 equals 0. Okay, I'm just going to put an or here. Okay, or I could solve it this way. If there's only one x term, you can just isolate the x. Get the x by itself. What would I need to move away from that left side first? I'm trying to get x by itself. The 36. So I could add the 36 to the other side. Now, how would I get rid of that squared? Not dividing. The opposite of multiply is divide. What's the opposite of square? Square root. So I could take the square root of both sides, but the thing is, when you take the square root as a step in solving, you have to remember that you need to take the positive and the negative. Because the square root of 36 could be positive 6, it could be negative 6. Because 6 squared is 36, negative 6 squared is also 36. So you get positive or negative 6. Aren't those the same two answers we got doing it this way? We just got them separately. So when you have only a single x term, you can solve it this way by isolating the x. Okay, the tricky thing is if you forget the plus or minus, you're going to be missing one of your roots, one of your solutions. Okay, so using the difference of squares factoring method guarantees that you see there are two separate factors. So you have two solutions. Okay, and I could have done that over here as well. I could have come over here and solved this. Whoa. I would have added the 144 to both sides to get x squared equals 144. And then I would have taken the square root of both sides. And remembered I have to put plus or minus. And gotten the square root of 144 is positive or negative 12. And that's the same thing I got separating it by factoring. Oh my gosh, quit scrolling. Okay, so really on these types, you have an option on how you want to solve those. You can use the difference of squares factoring, which separates the two factors. Okay, or if they're just asking for a solution, you could just solve for x by isolating it since there's only one x term. Now you can't do that when there's multiple x terms. Okay, so on these next examples, I can't just solve for x because there's more than one x. So here in C, there's more than one x term. Okay, I can't just isolate the x. So I am going to have to factor, and in this case, I am going to do GCF because these both have what that they can be divided by. Say it again. Need both of those. 5x. They both can be divided by 5, and they both can be divided by x. Okay, so 5x is my GCF. And then I'm going to put in parentheses what's left. So the 5's reduce. X cubed divided by x will leave me with x squared. Then we have a minus, and then the 5's reduced, the x is reduced. That leaves me with just a 1. It is not a 0 that you are left with there. 5x divided by 5x is not 0. It is 1. Anything divided by itself is 1. Okay, so make sure you have that 1 there. So now I've got it factored. I can split and solve. Now here's where you've got an option. This factor that I'm left with is a difference of squares. So that can be factored further, or you can do this method here with it. Since there's only one x term in the factor, I could just solve for x. So I could go ahead and split and solve this and set 5x equal to 0. X squared minus 1 equal to 0. Over here, obviously, if I divide out the 5, it's still 0. 0 divided by anything is still 0. So x equals 0 is one of my solutions. But once I get here, I can choose, all right, I'm going to do difference of squares factoring. Okay, which would give me x minus 1 and x plus 1. And then I would split and solve that further. And I would get -1 and +1. So this graph has 3 solutions because it is not a quadratic. Okay, see, it was a cubic. It was x cubed. Okay, so when you're solving polynomials, okay, if it was a quadratic, the most solutions would be 2, but this one was a cubic. Okay, and if you wanted to, this factor on the right, I showed it with difference of squares factoring. You could have moved the 1 over by addition, then taken the square root, and remembered when you take the square root, you need a plus and a minus, so +1 and -1. All right, let's try some of these on the back. So on the back, I've got a trinomial. So this is similar to what I was doing yesterday in the notes. But notice all of those have an x term in this trinomial. Okay, this is not a quadratic trinomial right now. I'm going to factor out an x from everything. So I'm going to first do GCF. That's going to leave me with x squared minus 4x plus 4. Okay, now that trinomial in parentheses is a quadratic, and I can use the x method. Okay, so I'm going to use the x method for this part that's left. So I'm looking for what multiplies to that c value of 4, it's positive, but adds to this b value of -4. So what multiplies to +4 but adds to -4? -2 and -2, both negative, so that they multiply to a positive, but add to that -4. Okay, so that is going to be x minus 2, x minus 2. And then I've still got that GCF of x in the front that didn't go anywhere. It's all still equal to 0. So now I'm ready to split and solve. Now the thing is, these two are exactly the same, aren't they? X minus 2 is there twice. Do I need to solve it twice? Okay, so I'm just going to ignore that one for now because I don't need to solve it twice. So when I split and solve, I'm going to have x equal to 0, and I'm going to have x minus 2 equals to 0. I only need to solve it once. So I would add the 2 to the other side. So I get +2 and 0 as my solutions. That's where x crosses, or the graph crosses the x-axis. All right, let's try E. Is there a GCF that we can take out first? Can all 3 of these be divided by something? By the same something? They can all be divided by 3, and they all have an x, so they can all be divided by x. So I can factor out a 3x from all of that. So that's my GCF. And when I do that, that's going to leave me with x squared plus 2x. And again, that's going to all reduce to just +1. So I did my GCF. Now with my trinomial that's left, I'm going to do my x method. Okay, so what multiplies to 1 but adds to 2? My c value was 1, my b value was 2. But what are the only factors of 1? 1 and 1. 1 times 1 is +1. 1 plus 1 is +2. So this is another one that factors to the exact same thing. X plus 1, x plus 1. We've still got that GCF of 3x in the front, and it's all still equal to 0. Okay, so I only need to find the x plus 1 twice. Oops. So that's going to be -1. And then here, dividing by anything, 0 divided by anything, still 0. So 0 and -1 are my solutions for E. Okay, I can say the same thing here. Those were both duplicates, so I didn't need to solve it twice. All right, let's take a look then at F, last but not least. Okay, so this one has 4 terms, and actually there is, I think, a typo here. So everybody with me, we're gonna fix this. Right here in front of the 3, instead of a plus, that is supposed to be a minus. So go ahead and change that. Put it in red. This is what I changed. I made that a minus right there. All right. So got 4 terms. Okay, this is where we use grouping. Okay, so we group the first 2 terms together. And then we group the second 2 terms together. And then we're going to find the GCF of each group. So in the blue set of parentheses, what is the GCF amongst those 2 values? X squared. So an x squared can be factored out of both of these. So x squared, and then I'm going to put in parentheses what's left for that blue set. So when I divide that, I'm left with 2x plus 3. Okay, and then in orange, what can be divided out of both of these? The only thing they have in common there is that negative. Okay, so we're just going to take out that -1. Remember, we don't want our lead term to be negative, so that's always going to be the case, but there's no other number or variable that they have in common, so just a 1. So -1 would make this 2x plus 3, which is the goal. When we're factoring by grouping, that's the whole point of this, is that your leftovers, remember that's what I call those, your leftovers are the same. That's a good sign. That means that that is a factor. So 2x plus 3 is a factor. And then what is our other factor? Who remembers the grouping process? X squared minus 1. You take the GCF that you pulled out of each of those groups and bring them together. So x squared minus 1. So that came there, and that was that repeated one. So these are my factors now, and it's all still set equal to 0. So now I am ready to split and solve. So 2x plus 3 equals 0, and x squared minus 1 equals 0. Now the last time we had x squared plus 1 on the front, I showed you difference of squares factoring. Okay, so this time I'll just show you I can solve this by isolating the x. And then I would have to take the square root, and when I take the square root as a step in solving, I have to remember that plus or minus. So I get positive and -1, because the square root of 1 is 1, right? And then on the left, when I go to solve this one, I would have to subtract the 3 over, and then divide out the 2. So this one, we get -3 halves. So -3 halves, and positive and -1. So there are 3 solutions here. +1, -1, and -3/2. So you could write those out separately down here if you wanted to. +1, -1, and -3/2. Okay, so solving by factoring, we've got to be able to use GCF, difference of two squares, X method with trinomials, and grouping. Okay, so we've done an example of each type of those factoring. Okay, it's just once you get it factored with whatever factoring method you had to use, it's still set equal to 0, and you split and solve. And you set all of your factors equal to 0 and solve them individually. Okay, and you can check all of these in Desmos. Okay, if I were to graph this original polynomial that was given, these are the 3 places where it would cross the x-axis. I feel okay about that? Okay, so we've got to practice in Delta Math. If you have not finished the ones from earlier this week or last week, okay, just keep an eye on those deadlines and work in order of nearest deadline. And anything that is late already with past credit available, past due credit available still, they're at 75% credit until the test next Wednesday. Okay, but if they're still showing up under the upcoming tab, get them taken care of before their deadline so you can get full credit.